So for the first one, what are we going to use as our common denominator to multiply by? Just y. Y is the only denominator there, so we're going to use just the y. So now as we multiply this, y times y is y squared. Y times 18 over y, well, the y's will just cancel out. So that gives us just 18 equals y times 9 is just 9y. We're good. So now we need to just solve this. It's quadratic, so we've got a y squared and a y. So to solve it, we need to set it equal to 0 and factor. Our y squared is on the left side, and it's already positive, so we're going to leave it right where it is. It means we're moving everything else over to it. So we're going to empty the other side of the equation. That's simply a 9y, so we're going to subtract 9y. So that's gone over there. It's 0 on the right side now. On the left side, we're going to go in descending order. So we have the y squared. Nothing to subtract the 9y from, so just minus 9y and positive 18. So now we need to see if we can factor that. Y squared minus 9y plus 18 factors to what?
Y minus 3 and y minus x, or 6.
Perfect. Y minus 3 and y minus 6. So that gives us two possibilities. Y minus 3 equals 0, or y minus 6 equals 0. We'll solve both of those real quick. Here we'll add 3 to get y equals 3. On this one we'll add 6 to get y equals 6. Now let's double check those in our problem here. If it's 3 plus 18 over 3, does that equal 9? Well, yes, that works. That's 3 plus 6 equals 9. If it's 6, let's try it. That would be 6 plus 18 over 6. Does that equal 9?
Yep.
Yes, it does. 18 over 6 is 3, so 6 plus 3 does equal 9. So both of those work. Y equals 3 and y equals 6. Any questions on that first one? Okay, number 2 is a little bit more difficult. When we look at this, we have three denominators, x plus 3, x squared plus 5x plus 6, and x plus 2. But you'll notice x squared plus 5x plus 6 is just x plus 3 plus x, or times x plus 2. So our common denominator is going to be the x squared plus 5x plus 6. We're going to multiply by that. And we'll remember that that simply is x plus 3 times x plus 2. So we'll go ahead and multiply. So we multiply the first term, 5 over x plus 3. Well, the x plus 3 is going to cancel out, leaving us with just x plus 2. So it's 5 times the x plus 2, which gives us 5x plus 10. Now I'm going to pause. Are there any questions on how I got 5x plus 10 there? Okay. Now for the next term, we multiply 11 over x squared plus 5x plus 6. Well, that whole thing cancels out. The x squared plus 5x plus 6 and x squared plus 5x plus 6. But what is left, we have to be careful, is a negative 11. Now we're at the equal sign. We multiply by the 3 over x plus 2. So now we can cancel out the x plus 2, leaving us with just the x plus 3 times the 3. So 3 times x plus 3, which is going to give us 3x plus 9. Now from here, what do we have to do next?
move the right side over to the left?
Well, we could start with that, but the first thing we want to do, remember, when we get into this form is always combine what we can. There you go. So we've got the 5x, positive 10 and negative 11 make negative 1. Now 3x plus 9. Now from here, we don't necessarily, we have to check to see what kind of equation it is. There is no x squared here. It's not a quadratic. It's just a linear equation. So we have to, if it were quadratic, if it had x squared, we'd try to set it equal to 0 and factor. Here it's just an x. So we're going to get the x on one side and then solve it as a simple equation. So we have 5x and 3x. Which one do we want to get rid of? 3x. So we'll subtract 3x since that's positive, which will leave us with what? 2x minus 1 equals 9. Perfect. From there, we will do what? Add 1. 2x equals 10. And then? Divide by 2. So x equals 5. Looking back at the equation, the biggest thing we need to double check for, we can put that back in if we would like to make sure we get the same answer, or to get that it works out, I should say. And it will. 5 over x plus 3 ends up being 5 over 8 minus 11 over x squared plus 5x plus 6. Well, that ends up being 11 over 56 equals 3 over x plus 2. That's 3 over 7. That actually does work out. Not very pretty, but it works out. The big thing we have to check for is to make sure that when we put it back in, none of our denominators ends up being 0. If it does make either of the denominators 0, then we have trouble. Okay. Any questions on that last one? Before we get into new material here, are there any questions off the homework that we had from yesterday? Okay, well, then let's look at the next step, which is word problems. We'll start out with maybe some simple number problems. We might have the quotient of a number and 8 increased by 3/4 is the quotient of the number and 6. Find the number. When we're dealing with a quotient, obviously quotient means divide, so we're going to turn it into a fraction to express the division. The quotient of a number of 8 and 8, the order of those numbers is very important. The quotient of a number in 8 is x over 8. If it were the quotient of 8 and a number, that would be 8 over x. The order they come in is the order they're divided in. Quotient of a number in 8 increased by 3/4 means what?
Add 3/4.
Add 3/4. Is, so there's my equals right there, the quotient of a number in 6. How do I express that?
X over 6.
X over 6. Good. Now this actually could be solved with just fractions. X over 8 could be thought of as just 1/8 x plus 3/4. X over 6 can be thought of as 1/6 x. we could solve it like that. But let's practice using our common denominators. For 8, 4, and 6 being our denominators, what would our least common denominator be? 24. Good. So now when I multiply here, 24 times x over 8, so 24 over 1 times x over 8. I'm going to cross cancel the 24 and 8, both divide by 8 to give me 1 and 3. Well, 3 times x is just 3x. I multiply 24 times 3/4. Well, that's one I can just use the calculator for if I want to. Or 24 over 1 times 3 over 4. I can divide out the 4 to get 1 and 6. Well, 6 times 3 is 18. We're at the equal sign. 24 times x over 6. So 24 over 1 times x over 6. I can't cross cancel the 6's. 6 divided by 6 is 1. 24 divided by 6 is 4. 4 times x is 4x. What do we do from there? Subtract 3x. Good. To get 18 equals x, and that's it. We're all done. Well, let's make it a little more interesting than that. The quotient of 4 and a number increased by 6 is the quotient of 5 and that number I should say the quotient of 5 and that number decreased by 2. So I'm going to give you about 15 seconds here. I want you to write that equation out in your notes. So the quotient of 4 and a number, that's actually going to be 4 divided by x, increased by 6 plus 6 is, that's my equal sign, quotient of 5 and that number, so that's 5 divided by x, 5 over x, decreased by 2. What am I going to do to solve this equation? What's my common denominator? X. My only denominator is x, right? So I multiply here, x times 4 over x. The x is canceled to give me just 4. X times 6 is 6x equals x times 5 over x. The x is canceled to give me just 5. Then x times negative 2 is negative 2x. So to solve this, we have to get rid of one of the x's. Negative 2 is the smaller one, so we're going to add 2x. 4 plus 8x equals 5. What's next? Subtract 4. 8x equals 1. And finally, divide by 8. X equals 1/8. Now, a slight change in the wording. There was a part of this problem that is a little fuzzy. I'm going to do a slight change in the wording that'll make it a very different problem. So the quotient of 4 and a number increased by 6 is the quotient of 5 and the difference of that number and 2. Very subtle difference here. Can anybody tell me what's changed here? What's going to be different in this equation?
Is it going to be x minus 2 down below now?
There, it's going to be 5 over x minus 2, exactly. Quotient of 4 and a number is still 4 over x. Increased by 6 is still plus 6. Equals the quotient of 5, and the difference of that number and 2 is x minus 2. This is a lot more complex equation, because now our least common denominator is found by simply multiplying those denominators together. X times x minus 2, which of course is x squared minus 2x. So now we will multiply through our equation. Multiplying 4 over x, well, there the x's would just cancel out. We have 4 times x minus 2. What's that going to give us?
4x minus 8.
4x minus 8, very good. We multiply times the next term times the positive 6. That's going to be 6 times x squared minus 2x, which gives us what? Six x squared minus 12x equals, on the other side over here, we multiply through. There's going to be the x squared, x minus 2 cancels out, and you're exactly right, Ezra. We have just 5x. Now we've got a lot of combining to do here. On the left side, we've got the 6x squared. We've got 4x and negative 12x is negative 8x. Minus 8 equals 5x. Now that we've combined, what would come next? Subtract the 5x. So now we have 6. Oops, what's that?
8 or 8? I just was wondering, is that 8 or 8x?
That should be just an 8. That was from up here, remember.
Oh, yeah, I got it. Yeah, got it.
So 6x squared minus 13x minus 8 equals 0. Now we're left with the task of trying to factor this. Maybe not the nicest problem I've given to you. 6x squared, I'm going to do it as 2x and 3x just to see what happens. Let's try minus 4 and plus 2. Does that work? Nope. But I can do plus 1 and minus 8. Let's double check that. See if we can get that negative 13x. 2x times negative 8 is Negative 16x. 1 times 3x. Positive 3x. If we add those together, what do we get? Negative 13x, and that's what we wanted. So yes, that is the correct factoring. So now we solve. 2x plus 1 equals 0, or 3x minus 8 equals 0. And we solve the two linear equations. On the left, what do we do first? Subtract 1, 2x equals negative 1, and then divide by 2. X equals negative 1/2. On the right, what do we do first? Add 8. 3x equals 8, and then divide by 3. Perfect. So we get x equals 2 2/3. So x is either negative 1/2 or 2 2/3. Any questions there? There is a whole classification of problems out there called work problems. Work problems look something like this. Kim can finish a job in 6 hours. Stacy can finish the same job in 8 hours. How long would it take them working together? When we have this type of a problem, a work problem, what we want to look at is the rate at which they work. This is a very generic wording here. It's just a job. But if it were a certain number of tasks that needed to be completed, well, the number of tasks that they complete in a single hour would be, that number divided by 6 hours, the total number divided by 6 hours, or whatever. Well, we're going to, rather than breaking it down into a number of tasks, we're just going to consider it to be one job. So the rate at which they work, the rate for Kim plus the rate for Stacy would equal their rate together. So Stacy's rate is one job in 6 hours. So 1 divided by 6. 1/6 of a job per hour. What would Stacy's rate be? 1/8. One job in 8 hours. We want to know their rate together, or how long. We want to know how long it would take together. Well, that rate would be one job divided by X, however long it takes them working together. Now it's a matter of solving this equation. Our common denominator here, we've got 6, 8, and x. Well, for 6 and 8, what would the common denominator be? 24. So we throw in x, it's just 24x. 24x times 1/6. I'm going to take a shortcut. Multiplying by 1/6 is the same as dividing by 6. 24x times 1/6 is 24x divided by 6, which is 4x. Good. Plus, what's 24x times 1/8? 3x. Good. Equals, what's 24 times 1 over x? Just 24. Good. What would be my next step? Combine like terms. 4x and 3x make 7x. 7x equals 24. So yes, we divide by 7, which is going to give us x is equal to 3.4285714 approximately. Or just 3 3/7. So take about 3 3/7 hours to finish that job if they work together. Any questions? So the key there is to find a rate and rates that have to be added together. That's just like if you said Kim makes $12 an hour and Stacy makes $15 an hour, how much are they making together? Well, 12 plus 15 is 27. Same idea, you're adding the two rates together. A similar problem to that dealing with rates is a distance problem. Frank travels 300 miles in the same amount of time, it takes Pat to travel 375 miles. If Pat is traveling 15 miles per hour faster, how long were they traveling? So again, we're looking at rates here. When we look at speeds, in this case, miles per hour, that speed is equal to a distance divided by time. But here what we're equating is not speeds, what we're equating is time. Same time. So if I rearrange that formula, time is equal to distance divided by speed. That's what is in this problem is going to be equal. Is Frank's time has to equal Pat's time. Well, Frank's time is 300 miles per hour divided by Frank's speed. I'm going to call Frank's speed x. That's going to equal Pat's time, or Pat's distance of 375 miles divided by his speed. Pat's traveling 15 miles per hour faster. So what's Pat's speed? X plus 15. Now we could multiply here. We could multiply the x and the x plus 15 to get a common denominator. But we don't have to here because it's simply one fraction equals another fraction. There's a simpler way to solve that, which is using that cross multiplying. We multiply this diagonal 375 times x is just 375x. That has to equal our cross product in the other direction, 300 times x plus 15. Now we go ahead and solve the equation for x. Nothing to do with the 375x so far, but we're going to multiply through the 300. What is 300 times x plus 15?
300x plus 4,500.
Perfect. 300 times x is 300x. 300 times 15 is 4,500. What's next?
Get x on one side, move the 300 over.
Perfect. We get x on one side by subtracting the smaller one, which is the 300x. So we have 75x equals 4,500. What's next?
Divide by 75, x is 60.
Divide by the 75, and you are correct. X equals 60. Is that what we're looking for?
Well, that's Frank, so Pat would be 60 plus 15.
So yes, that's telling us Pat's speed is 60 miles per hour. Frank's speed, 60 plus 15, would be 75 miles per hour. Is that what the question is asking for?
No.
No, it's...
That would be 300 divided by, their mileage divided by their speed to give you the time.
Yeah, 300 divided by 60 is 5 hours. Double check to make sure Pat's is the same. 375 divided by 75 is also 5 hours. So the time traveled was 5 hours. Any questions there? Okay, so our next step, working with these rational expressions. We've added, we've subtracted, we've multiplied, we've divided, but we have not necessarily done them together yet. We can run into complex fractions, in other words, complex rational expressions that require us to do combinations of those. For example, we might have 3x plus 8 minus 5x over 24 all over 5 over 6x plus 1 over 2x. There's actually 3 problems to do here, all in one. Our first problem to do is the numerator. Remember, it's order of operations. That fraction bar tells us we have to do everything on top first. So let's do that numerator. 3x over 8 minus 5x over 24. What's my common denominator going to be? 24 will be my common denominator. Now, this is not an equation. We can't just multiply by 24 and wipe it out. We have to convert to that common denominator. This is already in 24ths. What do I have to do to this to turn it into 24ths?
Multiply by 3 down the bottom.
Multiply by 3 in the numerator and denominator. Very good. So yeah, we have to multiply by 8 in the numerator and denominator, or sorry, not multiply by 8. We have to multiply by 3 to turn the 8 into a 24. So we multiply by 3 in the numerator and denominator. 3x times 3 is 9x, and of course 8 times 3 is 24. So we go ahead and do that subtraction. We combine the counts, we combine the numerators. 9x minus 5x is 4x, and we keep the same name, 24. That can be reduced. Both numerator and denominator here can be divided by what? 4. Good. 4x divided by 4 is just x, and 24 divided by 4 is 6. So on top here we get x over 6. Now we have to do the bottom. We have 6x and 2x for denominators. What's my common denominator going to be?
6x.
The 6x. So the 5 over 6x doesn't change. 1 over 2x we have to multiply by 3 again. So 1 times 3 is 3. 2x times 3 is 6x. So once again, we go ahead and we combine the counts. 5 plus 3 is 8, and we keep the name, 6x. Of course, both of those can be reduced by 2. Good. 8 divided by 2? 4. And 6x divided by 2? 3x. So that is x over 6 in the numerator divided by 4 over 3x in the denominator. Remember, this symbol here really does just mean division. So what this is saying is x over 6 divided by 4 over 3x. To divide, we multiply by the reciprocal. So that would be x over 6 times 3x over 4. X times 3x is 3x squared. 6 times 4 is 24. Can anybody see what the last step is we have to do there? Divided by 3. Both 3 and 24 can divide by 3. So that gives me x squared over 8. So that whole works reduced to x squared over 8. Any questions there? Well, let's look at another one. Maybe slightly more fun. So x over x minus y over x plus y all over 1 over x minus y plus 1 over x plus y. This one looks really ugly, and I won't lie to you, it's not the prettiest problem we'll do this semester, but it isn't terrible. Let's start with the numerator. X over x minus y minus y over x plus y. Our common denominator here is going to be just those two denominators multiplied together. So my first fraction is going to have to be multiplied by x plus y. So x times x plus y is x squared plus xy over the x minus y times x plus y. Minus, what's my second fraction have to be multiplied by on top and bottom? X minus y. Just the other denominator. So now y times x minus y is xy minus y squared over x minus y times x plus y. Now this is subtraction up here. So what that means is we have x squared plus xy. It's going to be a negative xy and a positive y squared. Of course, what that does, positive xy and negative xy cancel out. So that numerator has reduced to x squared plus y squared over x minus y times x plus y. Let's do the denominator. In our denominator, we have the same numerators we did before, we had the same denominators as we did before. So what do we multiply this first fraction by?
X plus y.
X plus y. Of course, 1 times x plus y is just x plus y. What do we multiply the second fraction by? By the other denominator, which is x minus y. What's that give us? What's what? X minus y, good. Over x minus y, x plus y. So now when we combine up here, what's x plus y plus x minus y? X plus x is 2x, and of course y plus negative y cancels out. So that's 2x over x minus y, x plus y. So now we have to deal with this division. So that is just x squared plus y squared over x minus y, x plus y, divided by 2x over x minus y, x plus y. What do we have to do from there? Multiply by the reciprocal. So the first fraction does not change. X squared plus y squared over x minus y, x plus y becomes times what?
X minus y times x plus y over 2x.
Perfect. X minus y, x plus y over the 2x. And now, of course, the x minus y cross cancels, x plus y cross cancels. We have x squared plus y squared over 2x. What do you think? Yeah, I totally agree. These are maybe not the most fun thing we'll do this semester. Let's look at one maybe a touch easier. So 7 plus 3 over x squared all over 3 over x plus x. So once again, we'll start in the numerator. How are we going to do 7 plus 3 over x squared? Well, first thing I'm going to do is I'm going to make that a fraction by making it 7 over 1. Now I need a common denominator. What's my common denominator going to be?
X squared.
X squared. So I have to multiply this first fraction by x squared on top and bottom. So it becomes 7x squared over x squared plus 3 over x squared. When I add those, I combine the counts. What's 7x squared plus 3? Trick question, it's just 7x squared plus 3. And we keep that common denominator of x squared. On the bottom, 3 over x plus x. I'll make that x over 1, so it's a fraction. What's our common denominator going to be? Here it's just going to be x. So we're going to multiply the second fraction by x on top and bottom. So this is still 3 over x, plus, what's the second fraction become? X squared over x, perfect. Now when we add, we've got 3 plus x squared, which I'm going to write as x squared plus 3, over, I keep my common denominator of x. Now we have to divide that. 7x squared plus 3 over x squared divided by x squared plus 3 over x. What's my next step? Change it to multiplication by the reciprocal. Good. So again, the 7x squared plus 3 over x squared doesn't change. This becomes times x over x squared plus 3. Now we can cross cancel. What can we cross cancel here? X squared and x both can be divided by x, can't they? X divided by x is just 1. X squared divided by x is just x. Now it really looks like we should be able to cross cancel x squared plus 3 and x squared plus 3. Why can't we? Yeah, this one up here is not x squared plus 3. It's 7x squared plus 3. It's slightly different. So we're going to multiply out what we got. 7x squared plus 3 times 1 is 7x squared plus 3. On bottom, we have x times x squared plus 3. Like I said on a test, I'm okay with you leaving it like that. If you multiplied it out to make x cubed plus 3x, I'm good with that too. I'm sensing that you guys really want to try one of these on your own. So 5 plus 8 over 3x squared over 1 over 6x minus 3x. I have you give that one a shot in your notes. We'll talk about it in about 2 minutes. Okay, so for the numerator here, we'll make that 5 over 1 plus 8 over 3x squared. We have to multiply by 3x squared on top and bottom of this first fraction. You know, it's 15x squared over 3x squared plus 8 over 3x squared. Adding together, 15x squared plus 8 is 15x squared plus 8 over 3x squared. Any questions so far? And the bottom part here in the denominator, our common denominator is going to be 6x. So we multiply by 6x on top and bottom here, giving us 1 over 6x minus 18x squared over 6x. One minus 18x squared is a negative 18x squared plus 1 over 6x. So I'm going to write out the division. 15x squared plus 8 over 3x squared divided by negative 18x squared plus 1 over 6x. We'll change it into multiplying by the reciprocal. So it becomes times 6x over an negative 18x squared plus 1. Cross-canceling, both of these can be divided by 3x. So 3x squared divided by 3x is just x. 6x divided by 3x is just 2. $15x squared plus 8 times 2 is 30x squared plus 16. And then, of course, that's over x times a negative 18x squared plus 1. Now, one of the reasons I wanted to do this example is in my math lab, it sometimes does a little changing around here. What it does, in order to express this as having a positive leading term or a positive first term, it might express this, rearrange it a little bit. Instead of having the negative here, it might factor out a negative 1 and write it as negative x times, this would now be a positive 18x squared minus 1. So what it has done is it's divided this piece here by negative 1 and put the negative 1 out here with the x. So if you see this expressed this way, what they've done to get from here to there is they've factored out that negative and put it with that first factor. Okay, so as we move on from here, we're going to get into some stuff a little more concrete again, get away from all this variable and symbol manipulation. Your next homework assignment is going to be on what we covered today, solving more of those equations and the complex fractions. But to finish up today and then going into tomorrow, we're going to be looking at equations of lines. So back to lines again. And we have a few standard or common forms of lines that we use. One of them is called standard form. The standard form of a linear equation is simply ax plus by plus c equals 0. That's one of the standard forms. The other standard form might look like this. AX plus BY equals C. Both of those are considered variations of standard form. Then there are graphing forms. In our first graphing form, the one that we learned first and the most commonly used is slope-intercept form. In other words, that's the y equals form. That looks like y equals slope times x plus the y-intercept. Y equals mx plus b. The other common graphing form was point slope. Point slope form was y minus y1 is equal to our slope times x minus x1. And depending on what information we're given, one form or another is easier to use. If I am given a graph and a line that looks like this, if I want to write its equation, I know first of all that the y-intercept, where it crosses that y-axis, is 1, 2, 3, 4, 5, is 5. The slope can be found by doing rise over run between those points. This is down 5 and over 3, so that's a slope of negative 5 over 3. So in that case, it's very simple to use slope-intercept form. Y equals negative 5/3 x plus 5. If I'm given that it has a slope of 2/3 and goes through the point 9, negative 5, it's easiest to use that slope-intercept form. Y minus y1 equals slope times x minus x1. So y1 is negative 5, so minus a negative 5 becomes plus 5. Slope m is 2/3 times x minus x1. x1 is 9, so it's just minus 9. And there's the point slope equation. Now, it's not very common that we're just given a slope and a point, but we might be given something like this. That our line is perpendicular to the equation y equals 3/4 x plus 7 and goes through the point 6,2. If they're perpendicular, what would the slope of that perpendicular line be?
Negative 4/3.
Perfect, negative 4/3. Remember, the only piece of information we want out of this original equation is its slope. Its slope is 3/4. A perpendicular is opposite reciprocal. This is positive, we make it negative. Reciprocal, this is 3/4, we make it 4/3. So that's our slope. It goes through the point 62. So it's y minus y1 becomes y minus 2 equals our slope, negative 4/3 times x minus x1 is just x minus 6. And there's that equation. What would the equation of that line be?
X equals 3.
X equals 3. Very good. A vertical line is always x equals whatever number it goes through. How about this line?
Y equals -1.
Y equals -1. Very good. A horizontal line is always y equals whatever number it goes through. Tomorrow we're going to continue with that, and we're going to look at more uses for lines. We're going to look at a couple of examples of problem solving with lines, and then we're going to start talking about functions. We've talked about these equations that relate, x to y. We're going to talk about what a relation is in algebra, so that relationship between the variables, and then we'll look at what is a special type of that relation called a function. For now, remember that the stuff that was covered today, is going to be reviewed in homework 9B. So if you get a chance to take a look at that between now and tomorrow, that'd be wonderful. Otherwise, you guys have any questions? Okay, well, we'll see you all tomorrow. Have a wonderful day.